I'm just going to use my whiteboard. Hi, everyone. I am recording this, so I'm not just talking to myself. I promise. Welcome to week 1 for the maths refresher course. This week is going to be fairly laid back. I think it might take about half an hour, 45 minutes at the most. And it's just about getting the basic number laws down pat. It's usually what I take my grade 10 students through to make sure they have everything down pat. So, well, I'm not going to ask a question. I'll use the whiteboard. The very basics of number laws is the square root. Well, how many times do I have to times a certain number by another number to get, say, 64? Another way for writing 64 is 8 times 8, or 8 squared, hence the square root. I'm going to write questions on the board, and I'll give like 30 seconds to a minute to answer each one, and then I'll go through. So what would the square root? The square root symbol is that one. You should all know it by now. I'm just going to stop sharing the screen. So we have 4 questions. We've got 4 minutes to do all of them, and then I'll go through them. This sign is the square root. I'm going to give everyone that's watching, if you're watching the recording, just skip ahead a couple of minutes, or you can work through it. Give everyone 2 minutes to answer those, and then we'll go through them. One more minute, and then we'll go through the answers. Okay, so this is they're basically the inverse of each other. So to figure out 4 squared, you could just write 4 times 4. If it was 4 cubed, it would be 4 times 4 times 4. So we know that 4 times 4 is 16. If we have, what is that? If we have, if you want to figure out another way, actually draw 4 boxes, box with 4 lines going each way, and that'll give you 16. 8 squared, same thing, 8 times 8. 64. Square roots are a bit different, but the way I find easiest, 1 times 1 is 2. Okay, it's not 1. 2 times 2 is 4. It's not 2. It's not 3. It's not 4. It's not 5. It's 5 times 5 is 25. Square root of 36. 6. Okay, 7 times 7 is 49. 8 times 8, 64. 9 times 9 is 80. So again, a really simple concept. I just want to make sure everyone was on the same page before we move into the hard stuff. Number laws, everyone remember there. POMDAS, PIMDAS, PIDMaths, depending on where you went to school. So this is what we call our order of operations. So brackets, indices, I know that says over, brackets, indices, multiplication, division, addition, subtraction. So if I had using our order operations, what would be the answer to that question? It's going to move relatively quickly today. This is just covering skills, not learning anything new today. Some of you might. So how would I answer that? And this is to get you thinking in high school and senior maths, breaking everything down step by step. So brackets comes first, 1 plus, so what's next in the order? Multiplication, we don't have any. Division, we don't have any. Addition, 6 minus 3, the answer is 3. Some people figure it out in their head and answer it as 3, but stepping it out step by step is what's required to get full marks. So that's POMDAS. Really, really important as you head into algebra and all the fun stuff in your high school maths. So we have the commutative law, the associative law, and the distributive law. These are the 3 cornerstones of algebra and really important to have a good ground. They teach them in grade 6 and 7 because in grade 8, 9, 10 you're expected to know them. So, simple test. What else have we got? So 1 minute to answer these questions that you can see on the board. And then I'll explain. Well, it will explain what the commutative law tells us. So 6 times 4 is 24. Obviously. 4 times 6 is also 24. 10 divided by 5 is 2. 5 divided by 10 is 0.2. 6 plus 4 is 10. 4 plus 6 is 10. 6 minus 2 is 4. 2 minus 6 is minus 4. So the commutative law states that we can rearrange an equation to make it simpler to answer the question at hand. But this only works with multiplication and addition. If we change the order, you get different answers. 4 times 21 is 84. 21 times 4 is 84. Works the same for multiple numbers. Sorry, it doesn't work the same. So 5 times 2 times 4 is what, 40? 2 times 5 times 4 gives you the same answer. So it doesn't matter what order in which you do these equations. When there's multiplication, when there's division or subtraction, you have to leave it as is. And there is a reason behind why we do this. So then we have, this is the commutative law, which says that we can rearrange multiplication and addition sums as much as we want. So next we have the associative. So this tells us that we can rearrange all of the numbers in the most convenient way when we're multiplying or adding. So if we were to have they should give the same answer. So 3 plus, that would be 7, is 10. Gives us 10. Now, this may not make much sense as to why this is important, but I'm going to test you, and I'm going to make it obvious as to why the order of the numbers and the way that you complete the equation will make it a lot easier for you. So, write these numbers down. I'm going to give you, again, this is in, I don't know if anyone got the slides that I sent out earlier, but what I want you to do is calculate them in 2 different ways. So you have 3 minutes to do that, and I'll stand here. Should be concentrating on the maths, not what I'm doing on the whiteboard. So what most people do is they add it up left to right. Okay, 26 plus 42, 48, 61, 65. Should equal 100. But I'll show you an easy way. Change the order in which these appear. Look for numbers that you can make a whole 10 out of. Okay. And then put them into brackets so that you're calculating the tens. So 60, 26, it's 4. So 40, 13. What's that give us? Should give us 100. But to me, that's a much easier way of doing it. So again, it doesn't matter how you do it, as long as you rearrange it in a way that makes the most sense to you. Some people will order them and change the order from highest to lowest, lowest to highest, which also makes it easy. The whole point is we can rearrange this to make life easier. All right, so now we're going to do, I'm going to speak a worded question. The question is also in the notes that I sent out earlier today. And then you're going to come up with an equation for how to solve it. So, Tom, this is probably made about 20 years ago because people don't go to GB Hi-Fi anymore. Tom went to the shops with $314 in his wallet. 314 is his starting amount. Kid's got more money than I do. He purchased Guardians of the Galaxy 2 for $35. He then decides to get some lunch at KFC and spends $14 before going to Rebel Sports and buying a new football for $35. What do I get from that? The kid has too much money. So 1 minute, how would you calculate that? So he started with 35 and then he spent that money. So, does it make sense? Or does it make it any easier? Was it easy to do it that way? Or could we rearrange the 35 and the 14? And this is the early skills that you need to have to really succeed in algebra. It's understanding how to manipulate the equation to get the answer. You could also do brackets minus in brackets 35 plus 35. You could then do, so that would then be that would give you hopefully $230. Okay, the next law for algebra, the next number law really, is the distributive law. I want everyone to tell me what is 7 times 16? So Izzy has it down. Instead of trying to do 7 times 16, we do 7 times 10 plus 7 times 6. Tell Izzy's been working with a math teacher for the last 3 months. So instead of now trying to figure out what 7 times 16 is, 7 times 10 is 70. 112. Makes it much easier. Again, I'm going to put some examples up here. So, again, I'll give you a couple of minutes to work on this, and then we'll go through it together. So, how can I make 4 times 18? There's 2 different ways we could do it. We can have it 4 times what plus what. We can write it out as or come up with 2 other ways. So I need 1 minute. All right. 4 times 10 plus 4 times 8. So writing 4 times 10, 4 times bracket 10 plus 8 is exactly the same as writing this. What about 4 times 19? How can I calculate that? Exactly. 4 times 10. That's right. So I don't know, maybe it's just taught overly complicated in schools, but these rules are really simple. So what are integers? Anyone have any idea? So integers are just whole numbers. Everybody's seen a number line before. And we use these 2 symbols. Okay, here's a test for everyone. which one is less than, and which one is greater than. Yeah, but I mean, which symbol denotes greater than and which one denotes less than? So if I wrote 5, what would that tell you? Five is greater than 4. So this is the greater than symbol. 5 is greater than 4. 4 is less than 5. Exactly. Okay. This is one where even some of my year 10 and 11 students get stuck with. Adding and subtracting numbers. We have positive numbers. We have negative. So if I add I'll get this is horrible. That's good. That's why I'm doing it. So if I add a positive and a positive, what do I get? Positive, yes. What if I add a negative and a negative? So you get minus 10. What about if I added 5? What would I have? So if I add 5 and I effectively take away 5, what number am I going to have? So I would have 0. I started with 5 and I effectively took 5 away. If I have negative plus a positive, still 0. So for positive plus a negative, negative and a positive, you find the difference and ignore the sign. Okay, now I'm going to put some up again. I'll give everyone 1 minute to get through as many of those as they can. So -5 plus -5. 2 minuses make more minus. If I add a minus to a plus, so which one has the greatest value? 8. So 8 take 5, it's 3. Let me stick the minus sign back on it. +5 minus -5. If you see a minus and a minus, make it a plus. That will give you 10. 100 minus 0, still 0. 85 minus 100, hopefully gives us -15. 100 minus 85 will give us. So again, lots of my senior students don't understand that, or they get tripped up by it. Okay, so we'll move fairly quick this week. If I asked you what that means, would you be able to tell me, or would you look at me like I'm crazy? So this, we're talking about algebra terms. So getting into the terminology into our heads. So this entire thing here is called a term. The 4 is called a coefficient. The n is called a pronumeron. The second of the 2 is called an indice. So now this is going to be a little bit not very exciting. So there's a load of rules for algebra. 8 of them. So if you have 2a and down, what that means is 2 times a. But we don't use the multiplication symbol, we just put the letter next to it. We always put the number in front of the letter. And in an equation, numbers with no letters are written last. So 6a plus 7, not 7 plus 6a. We're going to put this all into practice. And I'm going to step you through one, and then you do one, and I'll step through one. More. And the terminology here is called simplify and reorder. So any idea what the term simplify refers to? When it asks you to simplify, yeah. Sorry, I didn't see the chat there. Don't worry about what that means, the full N, it was just an example. So I want to get rid of the brackets first. So what do I have to do with the numbers inside the brackets? I'm going to times them both by this number here. So 5a so if you have a number on the outside, but can I add 5a and 5b? They're two different things. So 5 apples and 5 bananas doesn't equal 10 apple bananas, does it? Yeah. A and B don't have a value. We're not looking at the values, we're just purely looking at rearranging equations. What we need to do is reorder. Where does the number without a letter go? So it goes on the end. So I don't know if you guys got the slides I sent out, but there's on slide 16. Use this same process. Times the number by the letter in the brackets and expand the brackets. Then you put the number that doesn't have a letter on the far side. So we'll do one more practice equation. This one's multiplication. So we're still just simplifying and reordering. Any ideas where we start with that? So 5 times 5 is 25. What's A times B? Any ideas? AB, perfect. Yeah. When you're timesing the letters by each other, they still have to be alphabetical order. So there's a bunch of practice. If you check your email, maybe in spam, I sent out the materials for this, and on slide 16 and slide 18 is about 6 questions. We will go through these next week in the beginning before we move on to make sure that everybody understands.